Hi, this video will be a focus on probability with a single event. A single event means you really only choose once. For the event of and, which is an intersection, means you choose something that's both. But for or, that's a disjunct, that means you have to think addition. But you have to get rid of whatever is both, that intersection. Let's consider an example of a single event where you only choose once. And I created all these little circles and squares, and some are red and some are blue, and we're going to look at some probabilities of this. So the first thing I'm going to ask you is how many are here? And so you look at this and you count. A total of 15. Now, let's take a look. Let's consider the probability of choosing a red and then the probability of choosing a blue. So the probability of choosing a red, I would have to count. So I see there's 1, 2, 3, 4, 5, 6, 7. So that would mean 7 out of 15. Whereas the probability of choosing a blue would be all the rest of them that you see here. So that's 3, 6, 8 out of 15. Now, if I ask you the probability of a blue circle, I'm not just saying blue or anything or just circle. I'm asking you for the probability of their intersection. So even though I wrote blue circle, that's the same as saying the probability of blue and circle. And what you want to think there when it's only a single event is you want to think the word both, which is both blue and a circle. And you look at that, and that would be 2 out of 15. Okay. Now you try to find the probability of a red rectangle. Pause and see if you can do that on your own. You should have gotten 4 out of 15 because there are 4 rectangles that are both red and rectangles, and that would be here. Now consider the probability of red or a rectangle. That is not the same as and. That symbol that we use would be like red, or looks like a U, and then it's a rectangle, and that is not both. When I said to you about or, you want to think of addition. Or, the word or and this symbol, your brain needs to go to addition. So you're going to add those that are red. So you're going to find the probability of red plus the probability of a rectangle. Those are two different things. Minus the probability of both. That is that formula. So the probability of red is 1, 2, 3, 4, 5, 6, 7. 7 out of 15. The probability of a rectangle, 1, 2, 3, 4, 5, 6 out of 15. The probability, and I got to get rid of anything that's both a rectangle but also red. That would be 1, 2, 3, 4. 4 out of 15. And then that would add up and give us the final answer, which is 9 out of 15. Please note that this can be reduced to divide them both by 3. I would get 3 out of 5. It's the same thing. Let's try this again. Find the probability of blue or a circle. So now that's what you have to think about. Blue or circle. So you may look at this and be like, well, listen, it's not blue and circle. Remember, it's or. And or means it's going to be one or the other. So you want to think addition. That's that symbol. Nope, that's not that. This one, and you want to think addition because it's or. So, but you have to get rid of anything that's both blue in a circle. So first you got to do, I'm going to try this again. This is going to be, just so you know, the probability of blue plus, I told you addition, the probability of circle minus whatever is the probability of both. So go through it. Probability of blue, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 15. Probability of circle, that's 1, 2, 3, 4, 5, and that's it, 5. 5 out of 15. Minus whatever is the probability of both, and that's both blue circles specifically, that's 2 out of 15. That's what's happening there. And so you add those up. So that's 8 plus 5, that's 13, minus the 2, that's going to be 11 out of 15. Just so you know, another way to consider this is to go through each and every one and look at them. Like look at this first one here and go, hey, are you a blue or are you a circle? Well, not blue, but you are a circle, so I can count you. I can count this one because you're at least a circle. And then all of these that are blue get counted because it's either blue or a circle, so I'm going to count those. And all these that are red or not circles don't get counted. So altogether, that becomes 11 out of 15. So that's the other way to look at it. The other thing you can do is to create a table like I'm doing here. And the two choices are, well, you can get blue or you can get red, or you can get a circle or you can get a rectangle. All right? And so these are the different options, and you can make a little table out of it. And it would be good for you to know how to make this table because we use them a lot. Okay? So in the sides, you will notice I will have here, I'm going to have a little extra column, and you're like, hey, what else? There's only blue or red. No, those are going to be for the totals, okay? And then the total, the grand total of everything, we already know that that's 15. So that would be like the intersection of this total and that total. That's the magic 15, right? That's our grand total. And what we're going to do is we're going to fill out what we know so far. So we do know that we have some blue. Out of the blue, a total of blue, this is the total area. Our total blues are 3, 6, 8. We have 8 total blues. Our total reds are 1, 2, 3, 4, 5, 6, 7. 7 total reds. Our total circles are 1, 2, 3, 4, 5. They're all in a group there. Total circles 5. Our total rectangles are 1, 2, 3, 4, 5, 6. 6. And what should happen is you should be able to add down and be like, well, 5 plus 6 and 8 plus 7. So 8 plus 7 gives you 15, but 5 plus 6, I did something wrong. My total circles is 1, 2, 3, 4, 5. My total rectangles is 1, 2, 3, 4, 5, 6, 7, 8. Now, oops, that was 10. Sorry. So that now I have it right. So these two add up to the total. They add up to 10. These other two, if you go horizontally on the bottom of the totals, you will see that 8 plus 7 adds up to 15. And all these totals, it's all that adding up. So what's in this box here? This box. So this box says is the intersection that you can see it's circle and blue. So here's the blue circle, circle and blue. Circle and blue, that's 2. Rectangle. Now if I look at this, before even answering about how many, rectangle that are blue, I could add and go, hey, 2 plus what is 8? 2 plus what is 8? So I can say, oh, that would be 2 plus 6 is 8. That must mean that there are 6 blue rectangles. Are there? 1, 2, 3, 4, 5, 6. Yes, it works. without looking at my picture, I can go back to here and go to this next one, that spot. Now I can think about the concept of what it means, or I can look at it like a little puzzle. I have 2, and then I have plus something equals 5. Well, 2 in this missing spot, it must be a 3. And let me check. Do I have 3 red circles? Yes. So it all adds up. 3 plus what is 7? 4. That must mean I have 4 red rectangles. So I do. It's working.